Hello all. Good morning, good afternoon, good evening, uh, based on where you're attending this conference from. Today, I'll be talking about the exploration of slide ring gel kinetics using rheology. So first, what does a slide ring gel mean? Slide ring gels are these interesting materials which are made using a polyrotaxane, which is a molecular necklace as shown here. The macrocycles are bound using this using a difunctional crosslinker, and two polyrotaxanes are connected together to form a gel, which is referred to as a slide ring gel. It's called slide ring gel because there's these interesting properties that come from it, where the strings can actually move along in the rings, thus giving the impression that there's a ring sliding, hence slide ring gels. Kozo group in Japan came up with this gel first, and it's been very interesting. It has shown very exciting mechanical properties, but surprisingly, there's no knowledge about how gelation parameters change the gelation kinetics or the post-gelation properties. And that's what I want to do using this poster. So I employ rheology to kind of observe gelation by doing a time sweep. I track viscoelasticity at specific frequencies and strains across the gelation temperature or gelation time. And finally, for the post-gelation mechanics, I do a brittleness test. So what you see here is the first figure is a time sweep of a gel which was done at 60 degrees Celsius with 5% crosslinker concentration. And keep in mind that all of the gels are gelled using a 10 weight by volume PR solution in DMSO. So what we have here is the G prime increases as a function of time, so does the G double prime. These values are fitted using an equation called the modified Hill equation, which is a kinetic model that has been used primarily for concentration in pharmaceutical samples, but people have adopted this equation for gels as well. So we get some data, some fitting parameters from this, such as the G prime infinity, which is the Plattner modulus, the alpha value, which is the fitting exponent, and theta, which is the gelation half time. So basically the time at which the G prime is half of the G prime infinity value. You can see over here that the gel actually undergoes a nice transition from a liquid to an excellent solid as gelation proceeds. So this was carried out over 18 hours, and the shift factor, which I call AG, is just for clarity, it doesn't really have any physical manifestation, at least not that I know of. The T cross that you get from this, so you'll see here that T cross is the time past which you get G prime higher than G double prime. That was plotted against inverse temperature to get the energy of gelation, which corresponds well to a urethane reaction where there's excess alcohols compared to the isocyanate. Past gelation, I did some amplitude sweeps and observed this shear strain kind of behavior, where as you increase the temperature, the shear strain reduces, but the yield stress kind of stays the same. There's no trend in that. So to me, that tells that gelation at higher temperatures is making the gel weaker for some reason. Coming back to gelation kinetics, you see that the black axis here is theta in both these plots. So you see that concentration has a much stronger effect on gelation kinetics than temperature. Temperature only increases by an order of magnitude, whereas concentration changes it by 3 orders of magnitude. And what I'm referring to here on the right axis is the rate of elastically effective crosslinks, or rate of production of elastically effective crosslinks. So in conclusion, what we see is that concentration is the parameter that dictates how gel is going to behave. And it also has a significant effect on the gelation kinetics. Whereas temperature definitely hastens reaction and has some post-synthesis effect, but it's not too significant that we would prefer to do it at one temperature or another. This work is very important because no one has done this. And since polyrotaxane systems with HMDI as a crosslinker have been used in many different applications, I felt it was important to inform the community at large as to how to tweak the parameter space to get the right material that you want. So thank you for listening to my talk.